Good morning, good afternoon. Thanks for joining us and welcome to this webinar, Step by Step, the Higg FEM Verification Trail. We have come to the third webinar, the section 4, water use. And let me also just tell you that I'm really pleased that you are joining today. Thanks for joining, and I hope that you are all well and safe. So, just a few words about leadership and sustainability and myself. I have a long work experience now, always focusing on the sustainability area. I have also been responsible for environment globally at Adidas, and previously I have had similar roles responsible for sustainability at other corporations. Leadership and sustainability, we are quite a small company, but we are growing consistently, and we work mainly in the textile sector, but also in the retail sector. So we are expanding our scope as well. We do consulting, strategy consulting with the brands and retailers, but we also do a lot of work in the supply chain. And this will be our focus today. And just also, all of you probably already know all of this about the GoToWebinar control panel. We are all on mute today. We have a very large audience today, and we would like to ensure the best audio quality. But we also would like to hear your questions. So please feel free to send us your questions via the question function. You can see it here. And we will have time towards the end of the webinar to take your questions. The questions that we will not be able to respond to live in the webinar, we will respond to all of them via the newsletter. So after this webinar, you will receive a newsletter with the presentation as a PDF, with a recording, as well as the questions that we have responded to after the webinar. All right, so let's begin. Also, a call out about copyright. That's, of course, important. And now, the agenda for today. We will just briefly reiterate the purpose of the verification trail, and then we'll go into the section of the water use. We will give you also some water use examples towards the end of this presentation. We will have time for a question and discussion. We will also do a brief demo on the Higg portal, and we will have some information to share with you regarding our offers and about our company. And so let's go there to the verification trail and its purpose. And I see that we already have questions coming in. Okay, good, very, very good. All right, so the purpose of the verification trail is for you to gain a better understanding of the Higg index and the Higg FEM, of course, in particular, and its meaning for your company, for your factory. We will also take you through section-wise guidance through all the questions. And of course, it is important that you are acquainted, that you get requirements in the Higg FEM so that you can fill out the self-assessment really comprehensively and completely. And of course, then finally, that you can prepare also for your verification. And the verification process, here are a few steps. You complete the self-assessment, probably you already started doing that. And then you engage with a verifier, of course, preferably with leadership and sustainability. And in order to make a proposal to you, we do need to get some information about your factory, the size of the factory, number of employees. If you are using chemicals, for example, also in your manufacturing processes, this is important in order to know if you need a chemical specialist verifier or if we can work with a generalist verifier. But we have many chemical specialist verifiers, so in most cases, we can actually support you with that. And then you make your self-assessment via the VFEM available to the verifier. So this is also a call out for you. You have to have both modules if you want to get verified. You need the FEM, the FEM for the self-assessment, and you need the VFEM for the verification. So please make sure that you have bought both of them if you would like to go through the verification. And the final date to buy, especially the VFEM, but also the FEM, is the last day of October this year. So don't consider verifying in November, December, and don't buy the VFEM before that. So you need to have the VFEM also available before the end of October. We have every year, we have some factories who have forgotten this, and therefore I'm just calling it out, especially for you. And then the verifier will review your responses and the documents that you have uploaded, and just make sure that that the verification as such then can go smoothly. Sends also an agenda ahead of the verification. And finally, we have the on-site verification, which is what we mostly do, but especially last year, and it will be the same this year, unfortunately, due to the COVID situation, and there are lots of travel restrictions and difficulties in conducting the on-site verifications. Therefore, it is also allowed to do off-site verifications. And finally, we have the reporting closing meeting, and you can post your results on higg.org and also share them, of course, which is, of course, important for you to do. And there is guidance from SAC about the on-site verification and the off-site verification. So you can just click on the links shown here below, and then you can read in all details about the verification process. And then the overview here. Those are all the sections we have in the Higg FEM, and today we will talk about the water section. So fresh water has always been a scarce resource for our planet, as 97.5% of all water is seawater or brackish water. Even 75% of those 2.5% fresh water is tied up in glaciers, making only 0.625% of all water available for use. So only 0.6% of all water is actually available for use. And therefore, water scarcity and water withdrawal is such an important topic. So this is a map from the United Nations Environment Programme, and it shows the percentage of all available water that is actually used for 1995, and then we have an outlook for 2025. Water withdrawal is defined as water use that permanently withdraws water from its source, water that is no longer available because it has evaporated, been transpired by plants, incorporated into products or crops, consumed by people or livestock, or otherwise removed from the ground. And now, if you look at those two maps here, with a 30-year in between, you see that there is quite a significant difference. And to explain here what the color coding means. If you have the brown here, that means that more than 40% of the water has been withdrawn of the total available water. The light brown, 40 to 20%, the light blue, 10 to 20%, and the dark blue less than 10%. And we can just take the example of the United States of America, light blue in 1995, but light brown in 2025. So it has gone from 10 to 20% to 20 to 40%. Or we can take India as the next example, light brown in 1995 and dark brown in 2025. So what are we seeing here? Well, we see that water scarcity is getting worse and worse. And we have actually many countries that have dark brown already, and quite a few countries that have a light brown color. And therefore, one of the first questions, this is one applicability question in the water section, is to evaluate your water risks. And the picture shows here an example of what it can look like. So here we have the northern part of Africa, some Mediterranean countries, And you can see that the overall water risk is color-coded as well, with dark red meaning extremely high risk, etc., down to light yellow. And you are asked in this question to use one of those two tools, the WRI, the World Resources Institute, the Aqueduct tool, and the picture here is from the Aqueduct tool, or the Worldwide Fund for Nature, the water risk filter. Unfortunately, when I clicked on the link during the past days for the Worldwide Fund for Nature, I got a warning message that it was an unsafe link. I don't know why, but in any case, the WRI, the Aqueduct tool, is working. And this question is about understanding if your facility is in an area with an high risk or an extremely high risk. And then let's go to the overview of the section. And we have at level 1 only one question. This is actually the same as in energy. In energy, we also have only one question. So we need to know all our water sources, and we need to track them and know the consumption. And if you can do that, you already have scored 25 points, and you are already allowed to move on to levels 2 and level 3. And then at level 2, you can see we have lots of questions. And at level 3, we have only one question. So this is the structure of the water section. And now let's go to the first question, which is about tracking your water sources. So what you need to do is you need to select all sources of water for your facility. And then you should indicate the source, the quantity of water, the method to track your water source, the frequency of measurement, and you can also add comments. So this is a very simple question, I will say, but also important, and it's really the baseline for everything you do in this section. What is important here is that you will receive full points if you are completely tracking all sources of water that your facility uses. And then you will receive partial points if you are completely tracking at least one of your water sources, but are not yet tracking all of your water sources. So for some of you, you may have only one water source. Perhaps you are using only your own well, so you are using groundwater, or perhaps you are using only municipal water. But in some cases, we also know that you may be using water from different sources, perhaps also rainwater. And so in this case, please make sure that you know all the volumes and that you can track all the sources. Then you will get the full score. And we talked about that last time in the energy, when we talked about the energy section as well. And this is that SAC has actually provided quite a lot of new guidance related to the quality of data reporting. And I would like to go through some of this guidance here. So there are additional data quality checks that are requested from you. You should review your source data. You should compare your current year with historical data as well to make sure that you don't have any abnormalities. So if your production has stayed constant, the number of employees as well, and you suddenly use much more water, then there may be a leak somewhere. So you should then, of course, investigate what is the reason that I'm using so much more water. And then you should also ensure that the most recent and updated versions of data tracking spreadsheets are being used. And I'm preaching this a bit, but please, for all your data tracking, keep one table or a few tables, but even one table with several tabs would make a really good job. Keep all your data that you're tracking in that table, the calculations you do, the explanations you need to have at hand, and then of course the data, and keep it month by month, keep it year by year, and that will help you really over time to build a good a very good data management system and make sure that you always have a consistent approach to how you manage data. And then you should also ensure that the proper units are reported. So in countries where you may not be using, for example, just cubic meter, you may be using gallons or liters, other units, make sure that you report them correctly. This is, of course, extremely important because all the data may be used by, for example, by your buyers. Perhaps they make their own data reporting by exporting from your modules, and then of course the data needs to be correct. So that's really important. If you have assumptions, then review any assumptions, and then do not report data that is not accurate. Do not report estimated data if it is not supported by verifiable and reasonable accurate estimation. And how this will be verified, we as verifiers, we have an additional task. This is not new as such, but the focus is much stronger now on us to also make sure that the quality of the data is good enough. So we should review all aspects of the facility's water tracking program that could produce inaccuracies, including the initial data collection processes and the data sources, the process and tools used to aggregate the data, and if any inconsistencies or errors are noted, the reported information must, of course, be corrected, as with every other question in the Higg FEM as well. And so we would really like to see, we don't just want to see the numbers in the tool, we really would like to see your spreadsheets, how you are using, for example, invoices or your meters to know the consumption values that you have. And so we would want to understand that you have a robust process to collect and check your data. And then if we go now to the next question, this is the question about water baselines. Has your facility set baselines for the water use? And if yes, select all water sources for which your facility has set a baseline. And the intent here is for you to know what your starting point is. So a baseline provides you with an overview and a clear reference point for ongoing water performance tracking and target setting. And so the baseline is the starting point for your target setting, and the baseline is the value of which you will always compare your results with. So if you want to reduce your water consumption, you need to have defined your starting point. And the water baselines, they can be absolute, they can be normalized. There may be lots of different units, liter per kilo, liter per meter, liter per piece, liter per SEM, for example, standard allowed minutes. So there are lots of opportunities for you to define your own baseline. And if you have production processes that use water, then usually it is a good idea to normalize your baseline. Even if you don't have that, it may still be a valid option to normalize your baseline, but then based on the number of employees. If you're only using water in domestic processes, in wash basins and toilets, for example, then you can still normalize the value divided then by the number of employees that you have. And that is, and in the production, so it is good to know if your production is increasing, then probably your water consumption will be increasing as well. Then if you have an absolute baseline, then you may not be able to compare as well the results because you will just have an increased consumption, but you cannot say why you have that. If you compare if you have a baseline that is normalized, so you have divided with your production volumes, then you will have a baseline that can really be compared also year by year much better. Because if your production goes up, then your water consumption goes up as well, but your value, your normalized baseline, will basically stay then the same, and also your targets and your results will stay similar. And I want to give you here an example. So let us say that we have two sources of water. We have municipal water and we have well water, and each of them is 20,000 cubic meter per year. So in total, in 2020 in this case, we have consumed 40,000 cubic meter. And now our production, so our shipped volume, remember in the facility info section, you should include your volumes, but your shipped or sold volumes. And here we have a case where we have shipped 1 million pieces in this year. And then the calculation is 40,000 cubic meter divided by 1 million gives us 0.04 cubic meter per piece, which is 40 liter. So this is just an invented example, may not at all be applicable to your own production. But anyway, this is how you calculate, and that is what is important to understand how we calculate this number. And in this case, we have the result 0.04 cubic meter or 40 liter per piece. And of course, if we want to have the baseline then for municipal and well water, then the municipal is 20 liter per piece, and the baseline for the well water is also 20 liter per piece. And this baseline can now be used to compare your future water use data. So that is how the calculation is made. And now I want also to give an example again that we actually showed in the first webinar, and this is about the annual volume and the standard allowed minutes. So you should report the total amount of product shipped or sold in the last calendar year. And that amount should not include the total amount of rejects in the last calendar year. And you can select a unit, cubic meter, kilogram, meter, or standard allowed minutes, square yard, etc. Any unit that is applicable to your production. And in the case of standard allowed minutes, the standard allowed minutes is a metric that provides an indicator of the time allowed to produce a product by workers, including general allowances, efficiency, machine, etc. So it shows basically how much time do I need to produce one t-shirt, for example. And here now, in this table, you can see two examples. You have one polo shirt and you have one V-neck shirt. And you can see the processes, and then you can see the standard allowed minute per piece. For the polo shirt, we have 15 minutes, and in the V-neck shirt, for the V-neck shirt, we have 12 minutes. So that means that the polo shirt takes more time to produce than the V-neck shirt. And of course, if you have several different products and all of them have different SAMs, then the number of products that you produce per year will depend on the different categories that you are producing. And perhaps they are changing year by year. One year you're producing a lot of polo shirts, and another year perhaps you are producing a lot of V-neck shirts. And therefore we have introduced the standard allowed minutes, because if you calculate then your total standard allowed minutes per product type and per your factory, then you can actually compare year by year independent of the product types that you have. So in this case, we have for the polo shirt 100,000 products shipped, And for the V-neck shirt, we have 500,000. And this means that for the polo shirt, the total SAM is 15 times 100,000 equals 1.5 million. So 1,500,000. And the same calculation for the V-neck shirt, 12 times 500,000 means 6 million. And then the total SAM in this case is 7.5 million, 7,500,000. Okay? And so if you want to go ahead and use the SAM as your normalizing factor, you can do that. But it is, of course, for every factory, it depends what is the best. So you need to consider your own situation and try to figure out what is the best way for me to calculate my baseline. And now again, guidance from SAC regarding what you can do, what you should do when you develop your water baselines. So you should review your water use source data and draw normalizing metric data against totals in order to ensure that they are accurate. You should select the appropriate baseline type, absolute or normalized, and also please consider that when you decide about your baseline, you basically implicitly also decide about how to set your targets. So if you have an absolute baseline, then you should also set absolute targets. If you have a normalized baseline, then you should set normalized targets. We actually still see quite a lot of factories who does this different. So they may have an absolute baseline and then they set a normalized target. But of course, that doesn't make sense because that makes it, then it impedes the comparability. You want to compare your target, your actual result, and your baseline. So they need to have the same units, otherwise you cannot compare them. Okay, and then you need to ensure that the proper units are reported. You should enter the baseline year, provide sufficient details on how the baseline was calculated, and only select yes to the question if the baseline was verified, if the baseline data was fully verified in a previous Higg FEM 3.0 verification, and then of course you cannot change the baseline in the meantime, or you can also conduct an internal or external audit that should be conducted by qualified personnel. And do not report a baseline that is not accurate. Don't report a baseline that is based on insufficient data. And don't report an estimated baseline if it is not supported by verifiable and accurate estimation methodology and data. All right. And verifiers must review all source data and aggregated data totals for the baseline year, and or also records of baseline data verification where available. And again, if any inconsistencies or errors are noted, the reported information must be corrected. So the verifiers will ask you a lot of questions here, and please be comfortable with that. It is always, of course, for all questions in the Higg FEM, it is important that you can explain what you have done. And that leads me also to the piece of advice. Please make sure that when you respond to all questions in the Higg FEM, that you also add your explanations where possible, that you upload your documentation accurately and to the specific questions where they belong. And then it will be so much easier also during the verification. But of course, it is not the verifier's task to lead you through your own documentation. You should do that. So you should be able to explain how you have calculated, which document contains what, and how they are linked together. The water intensive processes or operations. So this is then the next step. So you need to know what facility processes or operations that use the most water. And of course, this is important in order to know where you should begin to set your targets. So this is, as a first step, you can map out your production processes together with, for instance, a site process flow diagram with identification of where usage is metered or can be estimated. And this can involve that you list all your equipment on the site that uses water and then identify them through meters, quick tests, or estimates how much water each item on the list uses. So this is also, of course, an important step, because when you set your targets, you want to have them be realistic for what your potential is as well, and of course where you are using the most water. And the next question, has your facility set targets for reducing water use? And if yes, select all sources of water for which your facility has set a reduction target. And here, in order to get full score, you need to target more than 80% of your consumption when you set your goals. And you will receive partial points if you set targets for water sources that make up 50 to 79% of your total water use. So if we go back to the example that we had with the baseline, where we had 20,000 cubic meter municipal water and we had 20,000 cubic meter well water. If you set a target to reduce only your municipal water, then that covers 50% of your total water consumption and you would get partial scores. So in that case, you need to actually set a target for both municipal and for well water in order to get your full score. And then there are a few simple steps that you can take. This is a very, very simplified diagram, but you can basically walk through the process here from the top to the bottom. You look at the source of water that you have and you ask yourself, can I eliminate the use of water at this source? Do I really need this source? And if you say yes, then you can implement a corresponding solution. And then you go to the next one. Can the amount of water used be reduced? And again, you can add that to your program. So in all cases, you walk basically here through all these steps here, and then wherever you have a yes, you can develop your own plan to reduce water here. And then, can water or wastewater be reused or recycled? Yes or no? And of course, in any case, should you ensure proper management practices are in place for wastewater disposal and discharge? And the formal targets that you set here now, we are still at question number 4 about the water reduction targets. The formal targets should include a baseline performance value, the targeted reduction, for example, 5% reduction per piece, the expected completion date, and it should be relevant to the site's most significant sources of water use, exactly like we showed and asked also in question number 3. And here is some additional information. The FEM requires that formal targets be set in order to be able to answer yes to this question. And when establishing formal improvement targets, be sure to do the following. Base the target on a formal evaluation of improvement opportunities and actions. So there may be a whole range of things you can do to reduce your water consumption or eliminate water consumption in some cases. But of course, they also must be realistic. So you need to evaluate what are the costs of those improvement opportunities and what are the actions I need to take. Do I have the resources to take those actions? And then you should also define the exact target quantity expressed as a percentage. So if you reduce your normalized municipal water consumption per square meter of fabric by 5%, and it should be based on a formal evaluation, of course. And then you should determine if the target will be absolute or normalized. If you have an absolute baseline, then you set an absolute target. If you have a normalized baseline, you set a normalized target. You should define the start date, the end date, and the appropriate measurement unit. And you should, of course, also establish procedures to review the target. And you should ensure that the target is relevant to reducing the site's water use. All right, so lots of additional information and guidance regarding this. And then We have, again, similar guidance as what we had for the previous questions and also in the energy section. Do review that the target to ensure that all aspects are covered. Do enter the targeted reduction or improvement as a percentage, and make sure to enter a negative percentage for a reduction target. Select the appropriate target type, absolute or normalized, and then also you should provide sufficient details on how the target will be met. In this column, describe the measures planned to achieve this target. So a lot of information that we are asking for here. You should not report a target that is not accurate. You should not report a baseline that is based on insufficient data. And sorry, it should actually be target here. Okay, and then you should not report an estimated target if it is not supported by verifiable and accurate estimation methodology and data. The verifiers again have the task to review all supporting evidence, the calculations that are available, etc., and to review also the facility operations in relation to its water sources and use to ensure that targets and opportunities evaluate are also relevant to the site's water use. And again, if any inconsistencies or errors are noted, the reported information must be corrected. So a lot of additional guidance here, and this shows also how important the data quality is. So please spend enough time to get your data collection and your data reporting correct. And here we have just very simple, very simple examples of two different targets. One is to reduce the production water use per square meter by 15% in 2021 compared to 2019. And the actions would be in this case to install countercurrent water recycling system for washing water, a 15% reduction, and also, oh, sorry for that. And you would also be able to save some money here. No, sorry, the water you would say would be 15,000 cubic meter per year, and there is a cost to this. There is a completion date, and there is someone who is responsible. So this is the type, this is perhaps still a bit high level, but this is the type of implementation plan that you can then make. And the next question is, does your facility have an implementation plan to improve water use? And there is a template actually available on the How to Higg. The link is currently an old one, but we hope that that will soon be updated by SAC and by Sumera. And because it's really helpful to have a template to add your implementation plan into. And some example of actions in your implementation plan are improving production efficiency, modernize compressors, upgrade machines, to use more sustainable chemicals that then also use less water, to do rainwater harvesting, to use zero liquid discharge and recycling. And here we also have a few examples of projects. The Sweden Textile Water Initiative, the PACT, the Clean by Design. Perhaps you are already involved in one or more of those initiatives. So they have parts of their programs are also focusing on water savings. And then the next question is about demonstrating improvements. So here we are asking if you are reaching your target, and you should report here if your facility has reduced your water withdrawal compared with your baseline in the reporting year, and then you should select all water sources that have been reduced. And here again, if you have reduced your water consumption for water sources that make up 80% or more of your total water use, you will get full score. If you have reduced them for 50 to 79% of your total water consumption, then you will receive partial scores. And here is what it looks like. We will ask to see all the items below and how they have been calculated. We should keep all reports in Excel. And also, of course, the quantity should be included with indication of unit of measure. And then there is also a question about the percentage change to track progress. And here you can see a screenshot from the Higg portal, from the module itself. And again, guidance regarding the actual data reporting. Do review the reduction data to ensure all aspects are covered and that the information is accurate. Do enter the improvement quantity either as an absolute or normalized value, depending on what your target was, and your baseline was. Select the appropriate units for the reduction. Input the percent change in the water use of the source from the previous year. Make sure to enter a negative percentage for a reduction, so -5 if it is a 5% reduction, and provide sufficient details and describe the strategies used to achieve this improvement. Here we really want to see, very often we see very short comments here, and we really want to see much more details about how you have been able to reduce your water consumption. Do not report improvements that are not accurate. Do not report improvements that were not achieved in the FEM reporting year. So here you should only report improvements that were done and achieved in 2020. You should not report an improvement that is absolute and relates to a decrease in production or reduced facility operations. And you should not report an improvement that is based on insufficient data. And the verifiers, again, we should go through all supporting evidence. We should have a look at the changes or actions to reduce the reductions, and we should, of course, take note if there are any errors. And the final question is, has your facility implemented a water balance or other analysis to evaluate the traceability of water? And here you can see an example of a very simple flow chart of such a water balance. It's not entirely complete, but it gives you an idea. You have to, for example, you have to report on your incoming water in the facility, the amount and the water sources, the quantity of water used during the production process. So you see here in this chart here, for example, we have a total incoming of 135, and then 35 goes into the production, 95 goes to the boiler, and 5 goes to sanitary needs. And then you should also indicate the quantity of water recycled or reused in the facility. So here in this case, for example, we have recycling after reversed osmosis, 10 cubic meter can be returned into the boiler here. And the quality of the wastewater generated should also be reported, the volume of water discharge after the own treatment, and also the frequency at which the water balance is updated. So lots of information here. And now I would like to give you some examples that are relevant for your facility's water consumption. I would like to show you a water use breakdown. And after that, we have some best practice examples from the Natural Resources Defense Council and their report on water best practices. And here you can see a simple breakdown in a factory that actually has wet processes. And you can also see here a few best practice examples. This is from the NRDC study, and actually this NRDC project is now the Clean by Design project. And you can see here leak detection, for example, preventive maintenance, improved housekeeping. You can save 1 to 5%. Reuse cooling water. You can save 2 to 9%. So those are just a few examples. Please go here if you have these types of processes and have a good look there, because there are also really good business cases included in those studies. So they are really very helpful in my view. Okay, and with that, I would like to take you to the demo. So let's go there. And you can see we are here in the water section. And the first question here is, how many days did your facility operate during this reporting year? And then you should use one of the following tools, the WRI or the WWF tool. In this case, we have used the WRI tool, and we have to respond here. Is your facility location rated as high, very high? Yes. And this is, of course, also something that we will check when we do the verification with you. We want to know, did you have the right assessment here? Because, for example, if you are a small water user and are not in a risk zone, then you will actually only need to respond to question 1 in this section. So it's really important that that we get this question right. And then the first question then at level 1 is select all water sources: fresh surface water, rainwater, groundwater, produced processed water, municipal water, etc. So there's a long list here. And then the question, does your facility track water use from any of its sources? If we have a yes here, then we get this pre-populated table with all the water sources that we indicated that we are using. And then we have the detailed questions here. Does your facility track use from this source, the quantity used, the units, the tracking method, and what was the frequency of the measurement? So, for example, continuously, daily, weekly, monthly, bi-monthly, quarterly, annually are the response options that you have. And then the next question is, has your facility set baselines for the water use? And here again, we have this table is then pre-populated, and we can say here, is it baseline? Is the baseline absolute or normalized? What is the baseline quantity? And enter the baseline year. How was it calculated? And was the baseline verified? And I really ask you here that you explain in detail how your baseline was calculated. Because, okay, if it's absolute, it's very easy to understand. But if your baseline was normalized and then you give here, for example, 0.35 as the value, and then you can see here that you can only, let's choose cubic meter. You can only choose cubic meter. You cannot choose a normalized unit. So of course, here in this case, we have divided by some value, and therefore we should explain how we have done the calculation. So because the units are not updated according to normalized, they are only given here for absolute. But this doesn't mean that you can only give absolute baselines. You can, of course, also choose normalized. But then you should explain really well how your baseline was calculated. And the next one, does your facility know what facility processes or operations use the most water? You should upload the methodology for identify the highest water use factors. Or if you don't have such a document, you should describe here. And so this is also, again, really important that you describe in all detail how you have estimated the highest water use factors or measured them. Okay, and then it goes on and on. So you can see here as well, has your facility set targets? If you say yes, then you get again the same list of water sources that you already indicated, and then you have several questions here that you should describe. So this was the very brief demo, and now let me go back here, and I will take your questions. So let us see if we have any questions from the audience. Yes, we have one case here. If our water meter has broken down, then it's influenced to, yes, and then we could not measure for more than a month. How should we complete the quantity data to the FEM? Yes, in this case, I would suggest that you make an estimation. Perhaps you can look at previous years and or previous months, how much you have used, and then basically make a linear approach to how much you think you have used in that month when you couldn't measure. But of course, I hope that your meters are being also maintained well, so that this doesn't happen, or that perhaps that you have double meters in those cases where this is really important to do. But in your case, I would suggest that you make a comparison with previous values. Yes, and then there is a question how to calculate the standard allowed minutes for laundry and dyeing facility. This is a very a specific question. You need to have a look at the different types of processes you have or productions that you have, and then see if it makes sense for you to use the standard allowed minutes. I cannot give you an example from your type of facility where this has been done. So this is something that you might discuss with your operations team and your operations people if it would make sense to develop an SAM for your facility. My facility type is cut sewing. No industrial ETP is available. How will I make a water balance diagram if I have no STP? But I have a water flow meter before discharging into the septic tank. Yes, in this case, you have to map out your processes and your different process steps that you have. So you have a septic tank and you have a flow meter there. So you can add those amounts that you measure in your flow meter to your septic tank. So it doesn't matter in that case exactly what you have, what type of installations, as long, of course, as they are in compliance. But then you describe the installations you have and you add the numbers and the values accordingly to your flow chart. We are not using water in our production process. What target we could choose? Yes, you can still save water in your facility. So you will have water that is used in the wash basin. Perhaps you have a kitchen, perhaps, and of course you have toilets as well. And there are, for example, water taps that you can use that have a lower flow that will reduce your water consumption, or for example, dual flushing toilets as well. Or one other possibility would be that perhaps you can collect rainwater and thereby also reduce the use of municipal or well water. Okay, if we don't have wet processing facility, we use mostly domestic water and this consumes the most water. Can we enter it as an explanation to the question which asks what process consumes the most water? Or do we need to have a document for it? No, I think you can use that as an explanation. Because of course, um, if you have wet processing, then you will know you have different installations, different machines that use different volumes of water. But in your case, you are only using it for domestic purposes. So you can have that as an explanation. But I don't know. Perhaps you have. Perhaps you are also. Uh, have irrigation, perhaps you have a kitchen, etc. And then it might make sense to, or it would be good to give this indication of where you are using the most water. Can we use estimated data and water balance? Yes, to some extent you can do that, as long as you can explain how you have estimated and what your calculations were. So remember the guidance that we have given to several of the questions regarding how to use estimations. And there is additional guidance in the How to Higg related to this as well. If we have rain harvest as water source, should we still have a reduction target? Yes, I guess you don't have only rain harvest as your only water source, but in any case, it makes sense to still have a reduction target. Of course, it is a very positive step that you have so much that you have rain harvesting already. So then I have a question. There is a question: what is the difference between normalized and absolute? Yes, when you get this presentation, you can go back to the example of the calculation. So an absolute value, if you use the 40,000 cubic meter that we were talking about in our example per year, then this is your absolute baseline, 40,000 cubic meter. And the normalize, there we divide by the actual, for example, production number, or the SAM, the standard allowed minutes, or the number of employees. So the normalization is that you divide your total absolute numbers with a certain KPI in order to create your normalized baseline. What is the difference from the FFI and WWF to determine the water risk? I actually don't know the details about their different methodologies, so I cannot tell. Another question, will we normalize our water data with per capita, so per employee, if it is not used in production process? Yes, I think that is a good idea to do. We only have domestic water use in our facility. How can we calculate with our baseline? Yes, you could actually normalize it and divide with the number of employees that you have. So perhaps you actually, although you are only using domestic water, perhaps the number of employees is changing year by year. And then, of course, your water consumption would be reduced or would be increased. And therefore, it makes sense to normalize with the number of employees that you have, because every person will just use a certain amount of water. Okay, so we are running out of time. And as I said, I will respond to those other questions in a written form, and you will receive it together with the presentation as a PDF and the recording as well. And with that, I would like to give you some final information. So at Leadership and Sustainability, we are both Higg FEM and SSCP verifiers and trainers. We can support you with the Higg FEM verification on site, but it can also be done off site, at least in this year as well. And the FSLM or the SSCP verification always takes place on site, but some documentation review can be done off-site as a part of that. We can also support you with training, or we can provide support during your self-assessment process when you are filling out the self-assessment. And you can download here a presentation about our supply chain services. We have lots of other services as well related to the work in the factories. And here you see how you can contact us. You can go to our booking page and book a time with me, or you can also send us an email, and here you have several contact persons that you can contact in different countries and regions. I also want to mention that we are a SETI@C accredited training provider, so we regularly give trainings on SETI@C. And here is an overview of the webinars that we are right now doing in the webinar series. We have already held 2 webinars, and the section water is of course today, and the future ones here. And when you receive this presentation, you can go and register also to those webinars here. And a final slide about our company. This is not the entire team. We have been growing and are growing continuously, but here you see some of our faces. And with that, I would like to thank you so much. Please fill in the survey immediately after this webinar. And thanks a lot for joining, and I hope to see you again in 2 days. And then we will talk about wastewater. Have a great rest of your day. Bye-bye.